So we're doing a little bit of review for the cumulative test, and today's part of the review is focusing on exponentials. Exponentials have an x in the exponent. Do you see on this problem where there's an x in the exponent? If the bases are the same, then the exponents are just equal to each other. Okay, so in a problem like this, you would just take this minus this, put it in the exponent, and the bases have become the same. All right, let's do a little harder bases the same kind of question. 2 to the x plus 2 equals 8 to the 1/3. No, that's actually terrible. 8 to the 2/3, sorry. Yeah, even that's not awesome. 2/3 x, there we go. That's much better, okay. Okay, so to start with, are the bases the same right now? No. Okay, can you make them the same? Absolutely. So rewrite it so they both have a base of 2. And that 8 has to change to a 2. So underneath this problem, here's what you do. This one's already got a base of 2, so you leave it alone. This one, you say it's 2, even though it's not. And that's the cognitive dissonance. You have to be like, wait a minute, it's an 8, but I'm saying it's a 2. So what do you have to do to the 2? Put it to the third. And now it is an 8. And then you bring down your 2/3 x. It goes right here. And now you'll have to do 3 times 2/3. Do you know what 2/3 of 3 is? 2/3 times 3? Well, you'd have a calculator. Take out your calculator. Everybody take out your calculator. You're right. And then figure out what 2/3 of 3 is. It's not incredibly hard, but you're not getting it, otherwise you would have said it. 3 times 2/3. 2/3 of 3. If you had 3 apples and you get 2/3 of them, 2/3 of 3. Say it loud. 2. All right, good. So that's just 2x. See this yellow part here? 3 times 2/3 would be 2. And then there's still an x. So it's 2 to the x plus 2 equals 2 to the 2x. Now the bases are the same, so the answer's already there. It's this equals this, but will you know how to solve that? Take a second to solve it. And then I'd like you to compare with the kid next to you. Unless that kid is taking the test, of course. The test on logs. All right, so x plus 2 equals 2x. Subtract an x from both sides. I know some people start by subtracting 2, but they're wrong. And you got 2 equals x. Do you get how subtracting 2 would have been a wasted step? Because one step right here. You have variables on both sides. You get rid of the smaller one. All right, cool. So did you even think about checking it to see if it works? That actually is true. You should check all your answers on a test. And this cumulative test coming up is a really big deal. I would be checking my answers whenever I could. So let's just make sure 2 works. I go back in the original problem, and if I put a 2 here, ooh, it's 2/3 of 2. I did that a second ago. No, actually I did something else. Hold on. All right, so I'm putting in x is 2 to make sure it works. Now, if you used a calculator, you could go 2 to the 4th and it would be 16. And then if you used a calculator, hopefully 2/3 times 2, it would end up being 4/3. And this would simplify down to 8 to the 4/3. And then I do the third root of 8 is 2 to the 4th is 16 again. Yay, it works. 16 equals 16. I double checked it. All right, do you have to double check? No, only the problems that you want to make sure are right, which on a test is probably a lot of them. All right. Sound like the dentist saying, do you have to brush your teeth? No, you don't have to brush them. Just only brush the teeth you want to keep. All right. So
are you going to check the answers on your test? Only the ones you want to get right. So your next one is, if you add exponentials like this, a lot of people are going to get this wrong right now, but do your best. Would you know how to solve this kind of exponential problem?
Try it. That says 3 times x minus 2 to the third minus 1.
Equals 8. If you're not adding 1 right now, you're doing it wrong. Dividing by 3 would be the next logical choice. But right here, you put it to the power of 1/3, and did you even remember to think about whether absolute value comes in? This is that test where when you do the square root on both sides, you end up with absolute value. Did I do a square root? No, I did an odd root. So I don't need absolute values on the x. Okay, so this just knocks that out. And I got x minus 2 equals third root of 3. Well, you've got a calculator for that. If you want to borrow one, I'd be happy to lend you one. I'm going to say it more forcefully. If you don't have a calculator on your desk, please come up and borrow one from me. Thank you. Anybody else that does not have a calculator? Because I don't want you thinking you know how to do this and not really knowing how to do it. All right, good. All right, so the third root of 3. Let's see, got 2 Aidens. Whoever answers first, say it. Square root of 3. Third root of 3. Come on, say it.
I just got 1.44.
1.44, is that what you got? Yeah. All right, good. Then I'm going to add 2 to both sides, and then that's going to be 3.44. Kind of close to pi. A little later this hour, we're going to have, if you want, I had 4 kids last hour competing. One kid did 100 digits of pi, but he did have a mistake in it, tragically. But it was so close. I threw his name in the hat anyways, because that's pretty impressive. And again, the offer was, I'll throw your name in the hat for a piece of pie, if you can do it as much as me. I've got 23 digits down. 3.14, 159, 26535, 89793, 283, 84626. That's how far I have it memorized. And if you can do it as far as me, you put your name in the hat. And there's going to be a pretty small number of people in the hat. So if you memorize that, I'm going to give you that chance to show me that later. All right. And some of you, whoever's got the most in the room, wins a slice of pie all for themselves. Okay, so next up, let's see if you remember how to graph these. Y equals 4 times 3 to the x plus 4. Let's put an XY chart here. All I need is 3 points in the asymptote. Again, instead of memorizing 3 points and then making all the transformations to it, I would just pick any point. Like, okay, I want to put in 0. Well, then I got to do 3 to the 4th, which is immense. So I better not use 0. I mean, you try it and you realize that's going to be huge. Okay, so not 0. How about -4? Because then I can make the inside small. And that's what Mr. Server said to do. Picks points so that it makes the inside small. So then 3 to the 0 is 1 times 4 is 4. Who had -4, comma 4? Nice call. The next one I'm going to put in is something close to -4, like -3. If I put in -3, -3 plus 4 is 1. 3 to the 1 is 3 times 4 is 12. Ooh, probably goes off the graph. Okay, so then I'm going to find some more points. If I keep going down, if I go to -2, it's just going to be really, really big. So I'm not even going to try it because I'm smarter than that. Hopefully you are too. Try -5. So put -5 in. -5 plus 4 is -1. 3 to the -1 is 1/3. Remember that? If you get a -1 exponent, that becomes 1/3. 4 times 1/3 is 4/3, or 4 1/3. I'm just going to say 4/3. It's about 1.3. I found 3 points, and given that these are all, this one and this one for sure would work. This one's just barely off the graph. I probably would have taken it. What if you had to have another one? Well, I guess I would try. I got a calculator, so I can put in anything I want and get anything I want. I'd try something like, well, I tried 3, 4, and 5. Maybe -6. That's going to be 3 to the -2. Okay, that's going to work out to be a really small decimal, so it should work. Putting in 3 to the power of -2. I get 0.1111, and I times it by 4. I get 0.44444. And that's a point I could graph. Because remember, you got a calculator. All right. Now, one last thought. The asymptote on these things starts like this. You've had a long time to forget that. You know, the asymptote's been the other way on logs. Exponentials, it's like this. Let me ask you this. I want you to ask the kid next to you, or tell the kid next to you, did this asymptote move up or down? Talk to the kid next to you. Did it move up or down? It's really critical to know that the stuff in here is the left-right stuff. That's a multiply by 4. If you're at 0 and you times it by 4, isn't it going to stay at 0? That asymptote does not move. That does not move up or down. It would only be if there was like a +6 out here. Then the whole thing would have moved up 6. Does that ring a bell? The asymptote did not move. It starts at 0, and unless you put something on the outside, it'll stay at 0. All right, so the asymptote's still here, and I graph these points, -4, 4, and -3, 12, and -5, 4/3, and this has got a slight curve to it, and it looks like it's curving that way, and it's going to not touch the asymptote. So there we go. Boy, it seems like it's moved way to the left. Yes, it has, and that makes sense from our graph. The +4 here, that means move to the left 4. All right. Do you remember that exponential growth normally looks like this? And it's just been moved over. Okay. All right. There's a good review. That's the stuff, the main stuff, the hard stuff from exponentials. There's a worksheet on that. So the next step is pull up that worksheet on your iPad. I want everybody to be working on that worksheet. On iPad today? Okay. For today, I will pull up the worksheet on the screen for you. It's copied on the first question. All right, so that's all the review I have for you for today. This was the exponentials part. The log part will be tomorrow.